All right, so I think we should start working through this one together. So we're trying to find the length of the arc, the length of the curve, part of the graph of this particular function on this particular interval. So we want to do exactly the steps that we have been doing up until now. So we want to start by taking the derivative. Always a great place to start. So the derivative f prime of x. So the derivative of the natural log of a different function is just going to be u prime over u. So in this case, u is secant of x. So that means the derivative of secant, that would be secant of x times tangent of x. And then we're going to divide that by the function itself. So we're going to divide all of that by secant of x. And we can see that the secant of x on the top is going to cancel out with the secant of x on the bottom. So we have just a really simple derivative. Our derivative is just going to be tangent squared of x. So after that, we want to take the square of the derivative. We want to raise the derivative to the second power. And of course, when we do that, we get tangent squared of x. So now we are ready to plug things into the arc length formula. So L is arc length. It's equal to the definite integral going from a to b. So in this case, we're going to be going from 0 all the way up to pi over 4. So going from 0 to pi over 4. And then on the inside, we're going to just plug in the square of our derivative, add 1 to it, and then put a radical over all of that stuff. So we're going to have tangent squared of x plus 1 all under the radical. And you guys can probably see that this is nearly identical to the last two problems we've done. In this particular section that we're working on right now, a lot of them end up looking something just like this, where we have something like this that can be simplified using the Pythagorean identities, and then something that just turns into a single trig function to integrate. A lot of them just end up being something of this particular form. So let's just continue. So we want to simplify before we even integrate, before we can even decide what integration method to use. So let's use the Pythagorean identity, specifically the one that tells us this, the one that tells us that the tangent squared of an angle plus 1 is equal to the secant squared of the same angle, theta. So this is just going to be a secant of theta under the radical. So the radical and the exponent cancel each other out. We're left with just the integral of secant of theta. So arc length is equal to integral from 0 to pi over 4 of the secant of, this time it'll be x, dx. So remember that the antiderivative of secant of x is just going to be natural log of the secant of x plus the tangent of x. And again, I have a video explaining exactly why that is on my YouTube channel. It's a particularly challenging integral to do, so I have a video explaining exactly how to do it. But we're not going to worry about that right now. So we just have, so we take the integral. We no longer have the integral symbol. We no longer have a dx. We just have brackets. So we have the antiderivative natural log of secant of x plus tangent of x. And then we are going from 0 all the way up to pi over 4. So let's go ahead and plug these values in. So we have natural log of secant of pi over 4. So let's go ahead and just write this off to the side of the page, figure out what these values are actually going to be. We want to find secant of pi over 4 real quick. So it'll help us to find out what the cosine of pi over 4 is, because cosine and secant are reciprocals of each other. So cosine of pi over 4 is going to be 1 over square root of 2. But if we rationalize it, we get square root of 2 over 2. So if we take the reciprocal of that, we get 2 over square root of 2, but then we have to rationalize again. So we're actually going to get 2 square root of 2 over 1. I think, hang on, sorry, I'm paranoid. I have to verify that. Oh, so this is going to turn into just a plain 2. So we have 2 over 2, cancel each other out. So it's just going to be square root of 2. I'm glad I verified that. Really glad. So secant of pi over 4 is going to be square root of 2. And then we have tangent of pi over 4. So there's a really special property with the unit circle in quadrants 1 and 3. In this quadrant and in this quadrant, that tell us that tangent and cotangent are going to be positive for both of these quadrants. So this is pi over 4, this is 5 pi over 4. So sine and cosine of this angle are both going to be 1. No, sorry, that cosine and sine are both going to be 1 over root 2. So tangent is just going to be 1. So tangent of pi over 4 is just going to be 1. And I'm getting that really scary message from Zoom telling me that my internet connection is really unstable, so it might just throw things into total disarray. You might have trouble hearing me. So I'm also going to type this message into the chat right now. So let me know if there are any interruptions, and definitely let me know if you'd like me to repeat anything. I'm happy to repeat anything you might have missed due to my own cruddy internet connection. So type that into the chat as well, just in case you guys didn't hear that last bit. So to continue on, we have natural log of square root of 2, and then we wanted to find the tangent of x. We plugged in pi over 4. We wanted to find the tangent of pi over 4. And we used the unit circle, and we found out that that's just equal to 1. So tangent of pi over 4 is equal to 1. So this is going to be natural log of square root of 2 plus 1. And then we're going to do, sorry, not a plus, but a minus. We're going to do minus natural log of, this is going to be just secant of 0 plus tangent of 0. And remember, we did this in the last 2 arc length problems we worked on together. We found out that all of this is just equal to 1. So we have natural log of 1. And natural log of 1 is just equal to 0. It's just asking us e to what power equals 1, and it would have to be 0, because anything to the 0 power is 1. So natural log of 1 has to be 0. This whole thing just becomes 0. What's inside the parentheses is 1, but the entire thing is 0. So that means that our entire arc length is going to be just this part right here. Draw a box around it. So this is the arc length of our particular function going from 0 to pi over 4.